Hello everyone. So on our last videos, we created our tiny Shakespeare GPT model. And however, now we can expand further on it and change it into an actual ChatGPT model. So yes, it's a ChatGPT bot that we will build from scratch. So we will add features like chat formatting, we will fine tune it on a certain tiny data set, and at the end we will be able to talk to it as an actual GPT model and get responses. So you might ask, why do we need these upgrades? Because right now our model only does text continuation. So if you give it a Shakespeare line, it just continues writing poetry. And this is not a chat model because the chat models need to understand their roles in a conversation. So generally there are three main roles in a conversation: the system, the user, and the assistant. So the system determines the rules and the personality. The user is us, who will be asking the questions to the model, and the assistant will be the model itself, which will answer our questions. So what we need to do is teach our TinyGPT model this conversation structure and later fine-tune it on example conversations. So if you guys are ready, let's go ahead and get right into it. So we can open our original code, and first we need to define these three special text tokens I spoke about earlier, which will tell the model who is speaking, right? So this is not magic, these are just like the text strings that we'll use. And basically the tokenizer will then split these models and teach the model how to utilize this pattern. So let's go ahead and write it down. So right after our imports, we will write chat system equals. We'll put the system, okay, in this format. And we should also put these signs. Okay. Then we'll write chat user equals user. Next, and finally, it will be chat assistant equals assistant. Okay, so these are the role tokens. They will these are the special text tags that will structure our conversations. And then after the tokenizer splits them into subwords, they help our model understand who is speaking. So first the system will like initiate, then the user will, which is us, we will give a prompt or ask a question, and finally the assistant will reply. So next, we need to build a function that converts the conversation history into one big string that the model can read, right? So basically, we will give the model the system instructions, then each user and the assistant's response, and it will always end in assistant. This is very important, so the model knows that now it's supposed to answer. So if we code this, we will go right after. We'll make the format dialog. Over here. Give it the parameters, system prompt, and messages. Then we'll put parts. Let's say F chat system and the system prompt. So then we make a loop for M in messages. So for each message, the role will be chat user if M role equals to user, and else If it's not a user, the role will be chat assistant. Okay. Now we need to add these parts using append. So let's say f role then f role divided by n slash n. Then we put m content dot strip slash n. So basically the slash n's are the new lines. Then another if statement, if not parts so if the -1 means the last one, starts with chat assistant parts dot append f chat assistant. And we'll put slash n. Then finally, we will return it. Return dot join parts. Finally, we'll add all these parts together and present it to the model as a string. So the next step will be to create a chat dataset. So we need to create some kind of tiny dataset which consists of example conversations. And this will be as a JSON, one file, which will give one conversation per line. So the main point here is to have a few, not too much, just a few high quality examples, which will teach, like, have a quality teaching to the model rather than a lot of files with messy dataset. So our model will learn the tone from these high quality examples. So in order to do this, we have to come over down to the class next token dataset over here. And right after that, we can make the supervised fine-tuning dataset. So we'll call it class chat sft dataset with a dataset parameter. Define, initialize, self, we'll call the JSON path, as we said. It will be JSON path here. Which consists string and the tokenizer, which will have the SPT tokenizer. Then we should say the block size, for example, set the block size for integer. Okay, so we set the self.block size equals block size. Self.token equals tokenizer. Self.tokenizer. So self.samples will create an empty list for now. We'll keep adding to these lists later on. Now we say with open JSON path are encoding the standard UTF-8 we'll say as F. So now we make the loop. So for each line in the file, example equals json.loads line system text equals example.get system. Then we say you are TinyGPT, and the messages from the example will say just messages for now. Okay, so now we make the IDs list just as an empty list for now. IDs and labels. Now we should make the system prompts, and we will make use of these IDs later on, which is ignored for the learning, by the way. So system IDs equals self.token encode F chat system, new line, and we'll say system text. And another new line, just so it looks clean. Then IDs.extend with a parameter system IDs, labels.extend, let's say labels.extend mine is 100. I'll just explain this in a minute. Multiply by length of the system IDs. Then this is to ignore the system text for the learning. Then we make another loop for M in messages if M role, let's say, is user, then segment equals F chat user, new line, and we'll say for chat user, yes, new line, and then we'll make the M with the content dot strip and new line. However, no, actually we don't need a new line. It's good enough like this. So this is similar to what we just wrote for the systems. It will ignore the user text as well. So now for the segment IDs, we'll say self.token encode segment, then IDs.extend segment IDs, and then labels.extend, let's say labels.extend minus 100 multiplied by the length of the segment IDs. Okay. So else, if it's not a user, if it's the assistant, for example, we'll also ignore this. So we say head IDs equals self.token.encode f, let's say chat assistant, and make a new line. So then we do IDs dot extend head IDs, and once again labels dot extend minus 100 multiplied by the length of the head IDs, actually the seg IDs. Okay, so now that we have ignored the assistant header, we need to learn the assistant content. Okay, the model needs to learn the assistant content, so it should not ignore this one. So let's write here assistant IDs equals self.token.encode. We'll say m content dot strip plus new line. Okay, and finally we'll put IDs dot extend asset IDs labels dot extend asset IDs. Okay, so that's it for the assistant content. Now we should make another, force the assistant to turn at the end, right? So it should finish the message at the end. So we'll put tail IDs equals self.token.encode f chat assistant new line IDs.extend tail IDs labels.extend, once again minus 100 length tail IDs and multiplied by the length of the tail IDs list. So now we should truncate and align for the next token prediction by using all the information we have given to the model. So simply we do IDs equals IDs block size, and we do labels equals labels block size, and then we check, so if the length IDs is less than 2, then we continue. Now x equals torch.tensor. Okay, so in our last series we discussed these x and y tensors. These are important to include. So let's say IDs minus 1 d type equals torch.long. So y equals torch.tensor labels, and now this will be from the first one till the end. Labels and d type equals torch.long. Finally, we add these samples. So we'll say self.samples.append x and y. Then at the end, we will basically just say define the length. Should be aligned with the first define. So let's check if they're aligned. Okay, one more. Okay. So here we will say define length self return length self.samples. Then define get item self, let's say I, and return self.samples, the last sample, right? So self samples dot, or the first sample actually, I. So we'll just show all the samples that from the number that we have given it, which will I. So now I just want to explain once more what we did here. So this will be the supervised fine-tuning dataset that we just add here for the model. So this will teach the model to focus on giving us the assistant replies, right? Because the system is already defined, the user will be us, we will give our own replies. So the model should focus on giving us the answers to our questions, so which will be the assistant. So we mask the user and the system tokens with -100. You guys saw I kept using -100 because so the loss ignores them. And actually this is the trick used by real chat model training. It's actually a very widely used method to ignore the loss. Alright, so today we laid the foundation for turning our TinyGPT into a real chat model. So basically what we did as a overall structure was we added the chat role tags, we built our conversation formatter, and we also created the supervised fine-tuning dataset. And this structure will help the assistant with learning and replying to us. So in the next episode, we're actually going to train this chat model and talk to it live. So you will see us having actually a real conversation with the ChatGPT model. Instead of just giving it a prompt and it will continue our sentence, it will actually reply to our questions and interact with us. So if you found this video helpful, make sure to drop a like and subscribe so you don't miss the second part. Thanks for watching, and I'll see you guys in the next one.